Hello everyone, I Dr. Sanjay Upreti welcome you to the channel Electrical Science by Dr. Sanjay Upreti. So in today's video, I am going to explain that how to find the equivalent impedance of a AC circuit. So this AC circuit is given here the resistances and inductances are connected in a series parallel combination. So this circuit can be visualized as a different impedances are connected like this one. So let me first assume that this first 2 mF inductor, it is a first impedance, that is Z1. It is connected between these 2 points. So and between these 2 points, one 3 ohm resistance and 10 millifarad capacitance is connected. So let me say this is a this is a impedance Z2, or similarly series connected inductance and the resistance, it is Z3. So this circuit can be basically visualized as a three impedances are connected in a, so Z2 and Z3 are connected in a parallel, and Z1 is connected parallel combination of the Z2 and Z3. So this circuit can be redrawn like this one. So this, let me redraw this circuit. So this one is a this is the first impedance Z1, and then you have a second impedance here, and then you have a third impedance here, right? So there are the three impedances are here, that is Z1, this is Z1, this is Z2, this is Z3, right? This is your Z1, this is your Z2, and this is your Z3. So equivalent resistance can be given like a resistive circuit. So Zin will be equal to the Z1 plus Z2 parallel Z3, right? So Z1 plus Z2 multiplied by Z3 and divided by Z2 plus Z3, right? So this the equivalent resistance can be find out by this one. So let me to check this all, right? This Z1, Z2 and Z3. So Z1, so these value of the capacitor is given in a microfarad, and this millifarad, and value of this inductance is given in a Henry. So these values of this capacitor and the inductors, they are depend on the frequencies. So this is given that this circuit is operated at a 50 hertz. So we will find the value of the capacitive reactance of inductance and the capacitance. So this one 2 mF resistance. So value of the capacitive reactance is given here, can be given as a 1 divided by omega c, and similarly value of the inductive capacitance can be given by the omega multiplied by L. Omega is the, and omega is given by the 2 pi f. So it is 2 pi f means that is 2 multiplied by pi value, take the value of the pi is equal to 3.14 and multiplied by the 50. So because 50 hertz frequency is given here, so it will become 314, or value of this unit of this one will be radian per second. So Xe1 for 2 mF, 2 millifarad capacitance, let us say this is the Xe1. So Xe1 will be equal to 1 upon omega c, or it is equal to the 1 upon 314 multiplied by 2 multiplied by 10 to the power minus 3. So value of this, if you simplify this one, so that comes as a 1.6 ohm. Similarly, Xe2 is a 10 millifarad capacitance. So value will be given by the 314 multiplied by 10 multiplied by 10 to the power minus 3. So it will be the 1/5 of this 1.6. So value of this will be given, because this is the 5 times 10 is the 5 times of the 2. So the value of the Xe2 will be the 1/5 of this one. So it will come as a 0.32 and ohm. Or value of the XL is equal to omega L, or omega is 314 multiplied by value of the L is given as 0.2. If you multiply this one, so this becomes 62.08 ohm inductive reactance. So we have find out the value of the Z1, Z2 and Z3. Value of the capacitive and inductive reactance. Resistance will remain the same because their values are independent of the frequency. So their value will remain 3 ohm, whatever the frequency is. So now this one is the, let me write first one is the Z1. So Z1 is equal to, I am writing here as a minus 1.6 ohm, which we have calculated XC, value of the XC. So here I am writing minus 1.6 J, or it can be written here as a, 1.6 at the angle minus 90 degree. Why I am writing this one? So I will tell you. Let me write first all the value of this Z1, Z2 and Z3. So Z2 value of the Z2 is the that is 3 or 10 microfarad. This is the 0.32 ohm resistance. So it will become 3 minus 0.32 J, right? Or then value of this will become 3.02 at the angle of minus 6.1. And Z3 is it is a 8 ohm resistance, 8, or this value inductance always come in as a positive, so it is 62.8 multiplied by J. It is a complex quantity, or it can be in a polar form. It can be written here as a 63.3 at the angle of 82.7. So now you must be knowing the impedances are written in a rectangular form and the polar form, right? So what is the rectangular form and what is the polar form? So I am giving you a very brief idea about this one. If we draw the impedance triangle, so that it looks like this one. For a RL circuit, it looks like this one. This is the value of the R and this is the value of the XL. Okay. XL is 90 degree ahead of the R because in the inductive inductance current lags by the 90 degree. So that is why this XL is coming at the 90 degree ahead. Similarly, the XC, the capacitive reactance comes at the 90 degree behind the R, right? If it is having a XL and XC, so then value of the Z can be given here by this one impedance triangle, right? So this is the value of the Z. So this is the real axis. This is the this is imaginary axis. So this impedance can be written here as a R plus J into XL. Right? Or if this angle is theta, so in the polar form, it will be written here as a Z at angle theta. So for the R plus JXL, similarly XC is in a negative direction. So capacitive reactance always written here as a R minus JXC, right? So in a polar form, it is written here as a Z at angle minus theta because this is the Z in a capacitive circuit. It makes the angle at the negative angle from the R. Z makes the negative angle from the R. So that is why it is angle minus theta is given. So in the first case, I have taken the angle 90 degree. 90 degree in this case because this R is here the 0. When R is 0, so this theta will become 90 or that will become minus 90. Z2 is 3 minus 3J. So this magnitude is given by the magnitude can be given by the 3 square plus 0.32 square. So it will come as a 3.302, or this theta is given as a tan inverse XC divided by R. So you need not to do all this calculation because in the scientific calculator this is given. You can convert any rectangular quantity to the polar quantity or polar quantity into the rectangular quantity. So you need not to do all this exercise because This facility is given in a scientific calculator. So just for giving you the what are the polar and rectangular form of writing this impedances or the phasors in when we are discussing the circuit. So this is like this one, right? So I hope you will you might be knowing all these things. Uh, you might be knowing all these things. So I am writing here this one. So Z in is given here as a so Z in given here as a so Z in we have calculated here is this one. It is like a Z1 plus Z2 Z3 divided by Z2 plus Z3 like we have find out here. So I will directly write here is the value of this one is the Z1 plus Z2 multiplied by Z3 divided by Z2 plus Z3. I will put the values of Z1, Z2, right? So before going into this one, so I would like to mention one thing. Whenever you are multiplying the two values, so then multiplication or division, it is very easy when you are doing in a polar form, right? And if you have to do the multiplication, sorry, addition or the subtraction, then you rectangular or in rectangular form is beneficial because in a summation or in a summation like this one. So let me write this one here first. So Z1 we will be taken into account later. So here I am writing just 1.6J, right, plus. Because I have to multiply this one, so I am in place of writing in the rectangular form, what I am using the polar form here, right? So in the polar form, the value of the Z2 is 3.02 at the angle minus 60 degree. 3.02 at the angle of minus 6.1, right? Similarly, multiplied by Z3, Z3 is your 63.3 at angle 82.7. Right? Or in the denominator, because I have to add these two things, so I would write in a rectangular form. In the rectangular form, so Z2 is given here as a 3 minus 0.32 ohm J. This is 0.32 J, right? This is 32 J. Or then Z3 is the 8 plus 62.8 into J. Why I have written this in the polar form, in the rectangular form and the polar form? Because in the polar form now I can simply multiply these two quantities. I can multiply and I will add these two angles. In the denominator I would add the real parts and I would add the imaginary parts. So then that makes this calculation very easy. So here, so Z in is equal to, so Z in is equal to minus 1.6 into J plus, if you multiply this one, so I have already multiplied this one, so this value of this will come as a Z2 Z3, it is coming here as a 192 192 well sorry 191 191.2. Or if you add these two angles, then the resulting angle will come here as a 76.6. 76.6, because this angle is the minus 6.1 or this is the 82.7. When you subtract this one, so this angle come as here as a 76.6, and in the denominator it will come here as a, it is 8.3, that will come as 11. Or if you add these two, minus 0.32 and 62.8, then it will come as a 62.448. 62.48 into J, right? This that you can see here, this is very easy when you are adding two impedances or two phasors, or when you multiplying, then it is very easy in the polar form. In the rectangular form it is very easy. Now you have to divide these two. So in by the for the division, ultimately we have to convert this 11 plus this rectangular form into the polar form. So the value of this one will become minus 1.6J plus 191.2 at angle 76.6 divided by. So I have this, you can do very by calculate in your scientific calculator. Just press the polar and then give these values of x and y. So it will give you the magnitude as well as the angle. So I have already calculated it here. So this is coming here as a this is coming here as a at angle 63.4, and this angle is coming here as a at angle 80 degree, right? This is the angle 80 and 63.4. Now it is very easy. You just divide these two values and subtract. In this case, you have added these two. Now, for the subtraction, you will basically you will subtract these two angles, or so then you will find the final angle. So the value of this will become minus 1.6 into J, or plus. I have calculated this one. So value of this is coming here as a 2 point. Uh, it is coming as a 3, exactly 3, around 3, right? So 3.0, and angle is coming here as a minus 3.4. Why it is coming minus 3.4? Because 80, when you take into the denominator, it will become minus 80. Minus 80 plus 76.6, it will become 3.4. Now the interesting thing is that you have calculated the one form is in a one Z1 is in form of a rectangular form. This is in a polar form. Now we have to add these two. So again we will have to convert this rectangular to the polar. So the Z in will become minus 1.6 into J and plus. So if you convert rectangular to polar from your calculator, in your calculator you will write the rectangular, and then rectangular give the value of r as a 3 and theta as a minus 3.4. So value will come here as a 2.99. That will come as a 2.99 minus, because angle is the minus, so second quantity will be coming here as a minus 0.18 into J. So now this is very easy. Now the real imaginary part can be added and real part can be written separately. So Z in will be equal to the 2.99, and when you add 1.6 or 1 minus 1.78, 0.18, so it will become minus 1.78 into J. Okay, so this is your finally equivalent resistance is this one 2.99. So the real part is always given, like in this one we have written this is the 3 ohm, the 3 minus 3J. The real part basically represent the resistance, and imaginary part represent the either inductance and the capacitance. If it is a negative, it means it is a capacitor, because in a capacitor this imaginary part becomes is negative, and for inductive part it is plus, like in Z3. So that means the value of this this is equivalent resistance. This can be represented here as a series combination of a resistance and one capacitance, right? So value of the resistance is the 2.99 ohm, and capacitance, value of the capacitance is the 1.78 into J. 1.78, sorry, not J. This is now we will be writing right here at the ohm, right? Now you can find the value of the C. So we know that the X is equal to 1 upon omega C. So value of the X is given here as a 1.78 and is equal to 1 divided by 314 into C. So value of the C can be find out 1 divided by 314, 1.314 multiplied by 1.78. So if you multiply this by the 1000, if you multiply it by the 1000, then it will come in the form of the millifarad. So if you calculate this one, it is coming here as a 1.78 millifarad. So this value is the 1.78 at the 50 hertz, and the value of the capacitor will be equal to the 1.78 millifarad. I think so. This total circuit can be represented by a resistance and the capacitance like this one. Okay. The value of the resistance is 2.99, and this one is a 1.78 millifarad. So I hope you will this video will be helpful to solve similar type of the problems. And if you enjoyed this video, so hit the like button and subscribe to the channel. And if you have any problem, then you can write on the comment. I will send you a link where you can send your problems in the picture form, or in the image form, or in the text form, in either way. Anyway, thank you for watching this video. Thank you very much.